Spirulina occupies an almost mythological position in the wellness supplement landscape. NASA studied it as a space food candidate. It has been described as the most nutrient-dense food on Earth. It is marketed as a complete protein that can replace animal sources in plant-based diets. Health food stores sell it in bulk, and a morning smoothie isn't considered properly optimized in certain circles without a blue-green scoop of it. The spirulina market reached $596 million in 2023 and continues to grow. The science behind these claims, however, requires considerably more nuance than the marketing applies to it. The protein content of spirulina is genuinely impressive by weight, approximately 60 to 70% protein in dry form, containing all 9 essential amino acids and qualifying for the complete protein designation on technical grounds. A tablespoon of spirulina powder provides about 4 grams of protein. The problem is that a tablespoon is a realistic serving size in a smoothie, which means the protein contribution from spirulina in practice is about equivalent to a small bite of chicken. When researchers refer to spirulina's protein content, they are describing the dry powder's composition, not a practical food source that could replace meaningful dietary protein in meaningful quantities without consuming unrealistic volumes. Bioavailability introduces additional complexity. Spirulina's protein digestibility has been measured at approximately 83 to 95%, which is reasonably high for a plant source. However, the cell wall structure of spirulina affects nutrient absorption, and studies suggest that some of the protein and micronutrient value does not translate as efficiently from whole spirulina as from equivalent food sources. The amino acid profile, while complete, does not approach the anabolic efficiency of animal proteins in terms of leucine content and muscle protein synthesis stimulation. The B12 situation is where spirulina creates its most significant public health concern, and it is one that deserves unambiguous statement. Spirulina does not contain usable vitamin B12 for humans. What it contains are pseudo-vitamin B12 analogs, coronoids that are structurally similar to B12, but biologically inactive and can actually compete with and block the absorption of genuine B12. Vegans who rely on spirulina as a B12 source, and product marketing frequently encourages this, may be suffering genuine B12 deficiency while falsely believing themselves protected. This is not a marginal concern. B12 deficiency produces neurological damage that is irreversible in advanced cases, and the confusion spirulina creates around this issue has real clinical consequences. Contamination is the other warning that requires direct engagement. Spirulina is a blue-green algae, and when grown in open ponds, which is the dominant production method, particularly in China, which accounts for the majority of global supply, it can become contaminated with other cyanobacteria that produce microcystins, which are hepatotoxic compounds. Third-party testing for microcystin content varies enormously across brands, and the quality control standards applied to spirulina supplements are inconsistent between producers. That spirulina also accumulates heavy metals from its growth medium means sourcing and testing transparency are not optional considerations for regular consumers, they are safety requirements.